Hello my dear students, once again welcome back to your online class. So in today's video, we'll be beginning a new chapter of your mathematics, that is the mathematical induction. So in this, we'll be learning about the two ways by which we can reach to a certain conclusion. The one being a inductive method and the other is known as a deductive method. Okay, so in inductive method, what we do, we start here with a specific case and then we reach to a general cases. Like for example, you are observing someone in a bus and when a bus suddenly stops, you see him that he is falling forward. Okay, the second time also what do? You see the second person. Again, the second person in the bus also, when the bus suddenly comes to stop, he tends to fall forward. So in the same way, we reach to a general conclusion that everyone sitting in a bus, when bus suddenly stops, all of them they will tend to fall forward. So that is known as the inductive method. Inductive method means if you see one thing occurring, after that the second thing, the third, the fourth, in the same way we can easily predict that the last thing that is going to occur will be same as that of the first one. And in a deductive method, what we do, we start with a general case and then we reach to the specific case. That means we derive the formula to prove a certain expression. So that is known as a deductive method. So here we'll be discussing about proving the different formula by inductive method. So there are three general steps to prove the given formula. Okay, so what three rules? Okay, not three rules, three steps. So the first one, we need to prove the given statement for the specific value, like for the value of t of 1, or you can prove it for t of 2 as well. Okay, so the given statement you have to prove it for the value of a given specific value, and then the second step we are going to do is we assume the given expression to be true for any value k. Okay, and assuming this, we prove that the given expression holds true for t of k plus 1. Okay, and then once you can prove these two steps, then you can write that the given statement holds true for all the possible values of n. So with some of the questions, we'll try to understand how we prove the mathematical expression using the concept of mathematical. You can see one example, like you need to prove this statement using the mathematical induction. And the question is x plus 4x plus 7x plus dot 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 bracket 3n minus 2 bracket close x equals to half n bracket 3n minus 1 into k. Okay, so this is what you need to prove using a mathematical induction. Oh, sorry, this is not k, this should be x. So we start with, let the statement be this one. So let t n be the statement. Okay, what is the statement? This itself is the statement, that is x plus 4x plus 7x plus dot 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 plus 3n minus 2 into x equals to half into n 3n minus 1 into x. Okay, so the first step we start is known as the basic step. Okay, so basic step. Okay, so in basic step, you will prove this value to be true for the value n equals to 1. So for t of 1. Okay, so taking only one term, 1 means the first term only. So here on the left hand side, I have x will be equals to, on the right hand side, it will be 1 divided by 2. So what value of n you took? The value of n you took is 1. Okay, so 3 into 1 minus 1 into x. So this implies that x will be equals to half, 3 1 is 3, 3 minus 1 is 2 into x. So 2 and 2 get cancelled. This implies that x equals to x. So it is easily proved that the statement holds true for, the statement holds true for n equals to 1. That means the statement t of 1 is true. Now the second step we'll follow is known as the induction step. Okay, so induction step. So in induction step, what we do, we assume that the given statement let Tk be true. Okay, so Tk be true means in place of n, I'll replace the value by k. So the statement changes into x plus 4x plus 7x plus dot dot dot, and then 3. Now instead of n, I'll be using x. 3x minus 2, oh sorry, not x, it is k. Okay, into x will be equals to half into the value of n means it is k, 3k minus 1 into x. So let this be equation 1. So assuming the statement to be true for any value k, now I need to prove that the given statement is true for the value of k plus 1. Okay, so now to prove the statement to be true for n is equals to k plus 1. Okay, so what we do? I add the k plus 1th term in the expression number 1. So on doing that, I'll get x plus 4x plus 7x plus, now how much is here? So it will be plus dot 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 3k minus 2 into x plus, now I'll add the k plus 1th term. That means here I'll write 3, now instead of k, I'll write now k plus 1 minus 2 bracket close into x. Okay. So now this implies that now from here to here. Okay. So from 1 I can write that this value will be equal to half of k. So this will be equals to half of k 3k minus 1 into x. Okay. And then plus there it is 3. So I'll simplify this one. So on simplifying, it will be 3 into, so this will be 3k plus 3 minus 2 into x. So this I'll get half k 3k minus 1 into x plus this I'll be getting 3k minus, sorry, not minus, 3k plus 1 into x. Okay, so if you take common means half. Okay, so it will be k 3k minus 1 into x plus, now since I took half as a common, so I'll multiply this with 2 into 3k plus 1 into x. Okay, so this will be equal to now half, inside the bracket you simplify it. Okay, I'll try to bring this in the form of this one so that I can prove it true for the value of k plus 1. So it will be 3 into, this will be 3k square minus k into x plus, there it will be 3 to the 6 k plus 2 1 is 2 into x. Okay, so after this x common from here, so I'll get this one as half into 3k square plus 5x plus 2 bracket close x. Okay, so what did you do? I took x common from this expression. So again now, so using the middle term, so find the factorize 3k square plus 5x plus 2. So on doing that, you will get this one as a product of k plus 1 into 3k plus 2 into x. Okay, so finally, now one more simplification step. So this will be equals to half. Now instead of n, I got there it is equals to k plus 1. Now into, now this side, instead of n, you take common in such a way that it gets common, like I took 3 common, okay, and then it will be k plus 1 minus 1 and bracket x. Okay, so finally when we compare the first given statement and this one, okay, so in the given statement, instead of n, here wherever there is n, on the other side it should be k plus 1. So you compare the last and this one. So it is half n. There it is half k plus 1 because I was trying to prove this one to be true for the value k plus 1. Okay. So here it is 3. Yes, 3. And in place of n, I got the k plus 1 minus 1 into x. So hence we can say that the given statement is true for all the values of n. Okay, so this is how we prove the expressions of the given formulas using the mathematical induction. So you can go through the many examples given in the book and try to solve as much as you can from the exercise book. So thank you. We'll meet in the next video again.